Hello, good afternoon. We just give ourselves 5 minutes. No, even less. For people are joining so that we can all be there. I'm Vincent Kitio from UN Habitat. Just maybe some housekeeping. If you are not speaking, close your microphone. Just put it on when you are speaking, and yes, so that will also facilitate. I hope we are all. Suleiman, are you there?
Yes. Yes. I'm coming.
Yes. Now, please make sure that we have this session recorded, because we have received a lot of email, people that saying that this meeting is clashing with other meetings, so but they will want to review it. Yes, so that'll be okay.
I think this session is being recorded. Thank you, Vincent.
Yes. So, yes, I will. Perhaps I will also request that we can put the question in. If there is any question, we can put them on the chat, or so that during the session, the question and answer, we will we'll just review it. That may also save us on time.
نعمل بس مش له بالتوقيت صار نبرين وك ما عندنا نبر بيات
تتكلمون
سوى
Okay. Good afternoon, everyone. I think we can start now because the session we have a lot of people attending, and then and also given that we have exactly 2 hours, I will just start now, and by welcoming all of you that are attending this community of practices of the urban basic services of UN Habitat that is being organized, which is this special session is being organized in collaboration with net zero carbon architecture as a solution to African housing challenges, which is a program funded by the European Union and being implemented by different partners, which I will not list all the names here. They will be presenting as well. Professor Lorenzo will make a presentation, as well as Professor Francois Garde. They will give you that occasion to explain, to give maybe a small insight on the program, on the project, African Europe Bioclimatic Buildings for the 21st Century, ABC21. This session is about net zero carbon architecture as a solution to African housing challenges, which, before starting, to acknowledge the great work done by Beatrice, that she has been very instrumental in bringing us together, and also follow up with the different presenters that are here with us today. And she has also helped us not only with the logistic, but also looking at also some of the substantive issue mentioned here. So we have a big panel of experts that are all working in the housing production, in housing design, in housing planning, in they are teaching design of housing. They are also developing policy. They are also developing tools that can help produce houses that are not only affordable, but that are also environmentally friendly. And perhaps that is the theme of the topic of today, that is net zero carbon architecture. So we have with us the different representative from different organizations that we have invited. We will have Patriarche. Delpech will make a presentation on behalf of Patriarche Architecture, which is an architectural firm based in France, but with work towards the world. I mean, they have offices all over the world, and one of their key interests is on green architecture or sustainable architecture. After that, we will have a presentation from Professor Pagliano Lorenzo and Professor Francois Garde that will be talking about African and bioclimatic architecture, the experience, the work developed during the implementation of the Horizon 2020 program, as I mentioned earlier on. Then we will have Daniel Weiss from Swiss Resource Center and Consultancy for Development, SCAD Consulting Limited. He will be making a presentation on low carbon building design for that has been implemented in Kigali, that is also ongoing, and which we are fortunate enough to have a demo house being built in our complex, UN Habitat, to be presented to the different delegates that will be attending our UN Habitat General Assembly in the coming two weeks. And then after that, we will have Professor Blaise Mempo, which will also present to us a tool developed by IFC, which is called the application. The tool is called EDGE, which is a program that helps building practitioners to design houses that are environmentally friendly and also energy efficient. And those are houses that we call them low carbon houses. And after that, we will have the presentation from Francois Garde, who is behind a new model of building houses using recyclable plastic named Utalo. Is an innovative. He will present to us how it is possible to use the different tons, the million tons of plastic that are polluting our world to actually transform it into a useful resources. So that is the different presenter of today, and quickly I just want to mention the fact that my colleague Christophe Lalande just excused himself because as we speak today, there is also a discussion on a resolution on housing, and then he has to attend that session. Just to say that UN Habitat, we have attending this session. We have different colleagues from Habitat, from within the headquarters, and also from the regional offices. They are also very keen in knowing what is happening in this particular sector of net zero carbon architecture. Just a brief definition of net zero carbon architecture. We are talking about today, we have climate change is taking place, is happening. Experts are telling us that this is happening because of the carbon that are being emitted, that are the real causes of climate change. One way of addressing it is to start building, to do activity, to carry out activity that can that does not emit carbon. And one of the sector where this activity can actually take place is the building sector, which today represent 40%, 30% of the whole greenhouse gas emission. So if we can start reducing that emission of carbon, we could achieve the 2050 agenda, which is on climate change, because expert and also the global leader has defined 2050 as the year where we should make sure that by that date we should be able to reduce to reverse the trend of the climate change. Therefore, net zero, the meaning of net zero is that we know that we cannot get rid of fossil fuel that is also causing climate change today. We cannot get rid of it as we speak. We can phase down the fossil fuel as we reduce our uses of fossil fuel. We can therefore compensate it with renewable energy or renewable resources. That's why we are talking about net zero, in the sense that the footprint that we create, the carbon footprint that we create, we try to compensate it. But the idea is that after 2030, 2035, we should now be aiming at carbon neutral houses that are really built without emitting any carbon. So the topic of today is about net zero carbon architecture that presents the different solution, the different strategies, the different policy that can be put in place to address the issue of housing. Why housing? What is the housing situation in Africa? Our statistics show that in order to achieve SDG 11, that is the SDG on cities and housing, we need to build by 2030, just in Africa, around 250 million houses. This is the housing deficit of Africa, of the African continent. You are all aware that majority of our urban dwellers are living in informal settlement. And these informal settlement, they are living in housing that are not adequate. And therefore, in order to eradicate these houses that are not fit for human consumption, we need to transform, we need to build new houses. So what we are saying is that we can actually, as we have this huge potential of housing to build by 2030, let's build them having in mind, using sustainability measure in mind. And that's why we are seeing the net zero carbon architecture as a solution to address the housing challenges. So this is the definition that I can put here. But again, towards the different presentation, we will show how this is possible. We'll see best practices that exist in the sectors. We will also see actual innovation that are taking place or that are to take place to make sure that we reduce our carbon footprint as we provide housing, affordable housing to the masses that do not have access to adequate houses. So with this, I just also wanted to mention one element that Christophe Lalande, who is the head of the housing program at UN Habitat, he mentioned the fact that in his remark, he wanted to highlight the importance of contextualizing housing design so that we make sure that housing, whenever we are delivering on the mass housing, we should also make sure that the environment and also the local culture has to be taken into consideration so that the houses does not just become a product, but it also become a tool. It also becomes something that is linked to local uses, to the local culture, and also to the local custom. He mentioned the fact that housing is a human need, and we need to make sure it's our duty as UN and also as a partner to UN, collaborator of UN, that we need to make sure that all human beings deserve a better housing, adequate housing that is also affordable for them. He concluded his point by saying that he's aware of the different innovations that are taking place. He mentioned the houses that are being built with 3D design, with 3D printers, but again, mentioning that these houses are still using a lot of concrete, and perhaps we need to continue thinking and see how this house could be built using natural material that does not emit any carbon. He sent his apologies and also wish us a better outcome for this presentation. So I will stop here and give the floor to Delpech from Patriarche. Grace, perhaps you can put Leah's presentation.
Hi, everyone.
Yes, hi, Leah. The floor is yours.
Okay, thank you. So yeah, my name is Leah, and I'm here online with Thibaut Nuc, who is a managing director at Patriarche. And we're going to talk today about our experience working on the sustainable housing. So we're going to go through some of the projects we have and some ideas that we are considering through the experience we have done, and some subjects we have to focus on in the near future and for tomorrow to find solution for the African housing challenge, which is the subject for today. So first we can present ourselves. So I don't have the hand on the presentation. I don't know.
Or you want to share your, you could also share your.
I cannot do it myself right now.
Okay,
I don't know if,
so great,
but
great.
if you want to change it for us, we can also do that as you prefer.
So I think, sorry, I just, I mean, Grace, can you just, either you change? I don't know how to do that, but,
Okay, I can share your slides here.
Okay, no problem. And I can just tell you when to change.
Okay.
Thank you. Okay, so just to present ourselves, so Patriarche is a family name, so it's a family business from like 4 generations. We have Damien Patriarche today as a general director, and we are working through what we call the augmented architecture. So we are very multidisciplinary skills within the office. And the idea is to reconsider all the building environment, having all the professionals within the office and trying to make the best of each other to provide the best building as possible. And we have today 700 people in the office divided in 10 different offices. Half of them are in France, and we have 2 offices in Canada, 2 in Switzerland, and 1 in London. And so yeah, we have all this kind of profession within the office, like going from the engineering part, the architectural, working also on the real estate part. So we have designed some buildings that we also manage today as the workplace management. And this makes us able to change the way of using the building and to provide some new solutions. Can change. So yeah, talking today about the sustainable architecture, I think we have to consider that we're gonna talk today about architecture, so we'll not talk about the urban scale, but we have to keep in mind we always keep it in mind when we talk about architecture. I mean, so about the urban planning, there is this UN Habitat goals that are good to always keep in mind in talking about the urban scale on well planning cities and well governed and efficient. So when we talk about the location of the cities, for example, that are sometimes we see some development going a bit out of town with the satellite cities or this kind of thing. So it's all this kind of crucial things to consider for growing the cities and building the cities. And so we can go ahead. And so we talk here about the mass, the quantity, the huge quantity of housing to provide, because we know that in the very near future, about 2050, we have more than 3 billion people to provide housing for. So we talk about very huge mass and a very emergency, because we have to provide very rapid solutions. And all of this reconsidering the affordability. So the idea is the question we ask ourselves today is which sustainable and affordable building to provide to answer these 3 needs of quantity, rapidity, and affordability. Yeah, so when we talk about the sustainability, of course, we're gonna talk about the energy and the conception of the building. So more we have efficient building, of course, we're gonna have less energy to provide, but it's also depending of the users. So we really believe on user-centric approach. So the energy needs, it's only when the energy needs go down and the building efficiency goes that we can provide sustainable building. So it's a very leverage of these two topics to work on to provide a sustainable building. So when we talk about sustainable building, we consider, if we talk about the African Housing Challenge, we cannot avoid to talk about the affordability. And here we consider two ways of considering it. There is a low-income class and this huge informal economy, including a million or billion people. And another part, the middle and the upper class, where for the middle and upper class, we talk more about modifying some image of the contemporary architecture and the expectation people could have and the production of housing. So it's more about modifying the way we produce already housing there. And for the low-income class, it's more about providing a very new way of conception that answer to the very urgent need and very mass productive affordable housing. So this is two ways of making with the same goals. So talking about the sustainability. So as I mentioned, we include within it the affordability and also the livability with considering the users mostly within the process of the making architecture. So from these 3 points, we are going to the 3 huge large topics we consider when talking about the sustainable and affordable housing. So the user-centric approach with providing quality of living and the energy consumption within the building and also thinking of the long-term using of the building with all the users evolution within it. And of course, the resources with providing like geo or bio materials within the building and always trying to lower the carbon impact within the construction. And also providing some probably new schema of very large and fast on prefab creation, etc. So about the user-centric approach, we are considering that today, like when we see on the diagram on the upper right, we have people who are buying housing, just buying the walls, you can say. And we consider that people, if we watch on another way where more user-centric, where people could buy, for example, square meters, and we have a co-investment of the housing. And this could adapt more the way people live in and the way the family are growing as well. So from a single person going to a couple, going to a family, and then the kids are going. So the houses can adapt the way people live, and all the building is kind of movable this way. So it's another way of investing that could make us lower the cost of the final users. Another approach it's to consider the ability within the architecture with a capable volume, for example, where we have an owner who buy a volume that can adapt to his way of living in the future. So, for example, if we have high volume, we can be able to put some mezzanine or even to add some rooms, depending of the people living in, depending of the moment of the life, etc. So it is within the module that we have the evolution. And this also brings some lower cost for the evolution of the building and the retrofitting, etc. So this is the approach on the volume. And here we have the same approach, but more on the floor plan. So depending of the use of the building, of the house, but more during the moment of the day, for example, and thinking of a more movable way of using the house during the day. So we consider it on the long term on the volume and maybe more about the daily life on the floor plan. So all this, new approach of living that can bring some new solutions. Sorry for that. It's a free day today in France, so we are all home with Thibaut and there can be kids around. Je suis désolée, Léo. So here's a project with bio and geo source materials that we have developed in Togo like a few years ago. And this is a kind of good shame we have made. So we have worked more than 20 years in Africa up to now, and we consider in this one some very interesting process to make the building. Like here we use the floor, the soil of the floor to make some round bricks to make the building, and with a training process with the people who work on the building and who provide some profession for even after and building some other village building in the village after. And the building was a very, even in the scale, very large, so it make it in a very we built a machine to make the bricks, etc. So it's the right approach on the resources to make some buildings. We can go ahead. Here's another project where, considering that we can, when we talk about the resources, it's about mixing the materials and finding the most affordable solution by mixing the materials and use the best of each for cutting the cost and for bringing the best structure for each materials. And we can find some, mixing of materials in the structure, etc. And we have made some other projects we can see after, with, for example, this one where we use some prefabrication solutions. So here it was a project of a shelter for homeless, where we made the modules off-site and bringing them with a crane and coming on site. And here we had like a structure considering the building, the modules to put in. So it's a way of prefabrication, and we are reconsidering it also in some other way, maybe on the facade solutions that might be more affordable for some other places. And talking about the energy for the sustainable and affordable housing, we consider that more we go off-grid, more we can be efficient. And for example, if we consider the energy as a service within the building and to include it in, from the conception of the building, and we can provide the energy through the building. And if we consider the whole chain from the beginning and even exchanging from the, depending of the use of the building, like we have this drawing just done here, like from housing going to offices, depending of the use, etc. So using the energy when we need it and to provide it on our sites, that can also cut the cost for the users and for the people who live in. So yeah, to conclude, is like we consider here the traditional way of making, that we use a lot of effort from the beginning on the design and build, where we don't have always the user considering in the process, sometimes at the beginning, and also a huge cost and work. And a huge amount of effort bringing at the beginning, and also sometimes on the retrofit after. So we have some very big moments to a big effort and cost to provide. And so which is not always easy to make, because for example, the retrofitting is a bit a lot of money to put on, effort, and sometimes bringing the users out of the building, etc. So this is not always too easy to implement, and this is the barrier we are watching today, and with buildings which are at the end no retrofitting, etc. So our thoughts are to reconsider all this diagram and to make it leaning it by like dividing the cost on each steps. So we can go on the other one, please. Yes, so here we can see that we are always trying by the user-centric approach to have the users on each step of the project, and also to lean the cost on all the process of the building and considering it at the on the whole life cycle of the building. And as we mentioned, with the capable volume or the or this kind of sharing investment, etc. So we consider it and we lean more it as with the possibility to provide it and to have a very longer sustainable building. And this is actually what we are trying to do within Patriarche with all the that we are making, but we are always trying to improve every day and trying to improve on each step of the project and each profession that we provide, and with watching all the business models and having all the stakeholders within it. Yes, so thank you.
Thank you very much, Patriarche. Thank you, Leah, for that presentation. That very presentation that really highlight the different points that need to be taken into consideration. You mentioned the fact that we should not just focus on providing housing for the low income section of the society, but we should also look into the middle and also the high income. This is very important, as you really put the presentation, talk about the fact that the user should always be the person that we need to have in mind as we design, as we plan, as we build houses for them. You all mentioned the issue related to the densities. That is very important, that need to be also taken into consideration. If we think about the fact that urbanization is growing rapidly, and I like those pictures where you are showing the sprawl. If we have to deliver houses just focusing on the quantity, we might also damage the environment in the process. And you also, when you were talking about affordability, one way is also to look into the incrementality, that we give a space to the user, and then they can gradually improve on that space. You mentioned prefabrication. We really enjoy. I mean, I enjoyed the example of the prefabrication that you presented, because building 300 million houses in the next decades will require innovation, not just in the design, but also in the construction. So retrofitting, very important. I think, yes, that was really a presentation showing the different solution, but also showing the practical example. So I will encourage colleague and participant to write your question in the box. Given that we have a lot of presenter, I will just give the floor to the next presenter, so that towards the end we can now open the floor for question and answer. Now I'm pleased to invite Professor Pagliano Lorenzo to make a short presentation, talk to us about the African Europe bioclimatic architecture, and also highlight some of the key points that need to be looked into seriously. I mean, when we are talking about a bioclimatic architecture, when we are talking about net zero architecture. Professor Lorenzo, the floor is yours.
Yes, thanks. Hope you can hear me. I'm trying to start. Okay, the presentation. Can you see my slide?
Yes, we can see it.
Okay, so I go very quickly to the presentation directly. Thanks for this invitation and the organization, Kitio and UN Habitat, which is, I take the opportunity to say UN Habitat is one of the key actors in the project ABC21. And So I would try to give one example of these guidelines that are part of the deliverables. And so just mention this issue of the importance of a common language, common definitions, and in particular about zero energy. The project has been run and it's ending this month. It has been run by a number of partners. Politecnico di Milano is the scientific coordinator. I would not mention all of them because of the time. I leave the slide on for a few seconds so you can see, and you will see that we have a number of very good and active partners from Africa and from Europe, various universities, various ministries. And the project made a review of the framework, of the boundary conditions, analyzed and developed.
Maybe Lorenzo, you can move to the next slide where you have the partner.
Yeah, I am moving to that one.
Because on my end, I can only see the first slide.
Ah, that's the problem. I'm on the second one. Okay, so I stop presenting. Let's see what's going on.
Lorenzo, if you want, I can present from my head.
Okay.
And then you tell me to move on.
Try.
I hope you can see now.
Good. Yes, yes. Thank you. Thank you.
So I go back. Okay, now I see, and I hope everyone is seeing the slide with the globe and the localization of the various partners. Is that okay?
Yes, yes. Please proceed.
Okay. Okay. So again, there are a number of reports that you will find on the website that are dealing with local materials and construction practices, case studies. Francois Garde will talk about that. Weather files for future climate, because we have to design for the future. Obviously, we are designing now for the rest of the century and building now for the rest of the century. And an update of technical guidelines which exist in many. So there is a review of existing books and good guidelines produced in the past, and some updates due to the new conditions. Let's go to next slide. There is also a lot of new advances. Sorry, not too much. Stop here. So there's been a lot of work to update and make more precise the energy assessment indicators and the comfort assessment indicators. I will focus on a few key elements of this, and in particular on the net zero energy over a year concept and its problems and possible solutions for those problems. Next. So the key indicator that we identify in the project and is identified as a key indicator in the standards is the energy need for heating or the energy need for cooling, which is the heat to be delivered to the space to be conditioned to maintain the intended space temperature conditions or comfort conditions for a certain time. Next. This has to do only with the features of the building per se, of the building envelope, and of the ventilation. It's independent of how we then produce and deliver to the building the energy. Is how much the building uses per se for its geometric and physical features. So if we go on, we see step by step that in winter there are losses due to transmission through the envelope and losses through the ventilation. We are sending out warm air and coming and bringing in cold air. So these are losses which can be compensated by free gains. The solar gains and the gains generated by people and appliances inside, the difference between losses and free gains is what still needs to be given to the thermal zone to keep it at a given temperature. And this is called energy need for heating. And this is physically defined in a univocal way, can be calculated. Building is calculated generally in every labeling, because the first step for the calculation, and differently from what we see here, delivered energy, which is the energy given to the larger boundary, which includes the building and the plants, which might be gas or electricity coming at the blue meter that we see here. And if we go on one step, we see the delivered energy, which is the sum of the energy need plus the losses of the system. And this delivered energy can be, no, just stop here, thanks, can come from local generation, solar panel on the roof, or from the grid. And if we go on, we can calculate to compare the various sources, renewable, non-renewable. We invented these primary energy factors, which take into account the losses between the point of delivery and the source. So, for example, gas might be, we extract it from a gas source, a gas region, and then we have transport it, and unfortunately we lose some of it during the travel, and we have to pump the gas to proceed along the pipes. So we have energy losses, which are taken into account in these primary energy factors. When we consider all the flows coming to the building, both fossil and renewable, we talk and we multiply each flow by the primary energy factor. In the next step, we see that we call the sum of all these flows multiplied by the primary energy factor, we call them total primary energy. If we consider only the non-renewable flows, one step forward, then we talk of non-renewable primary energy, because we consider only the flows non-renewable, the fossil, for example. One step more. So we have these various indicators: energy needs, delivered energy, total primary, non-renewable primary. The standard, sometimes in the labeling, only one indicator is used, primary energy, sometimes not even saying which primary energy. And the standard clearly tells us that this is misleading. We go one step further. To really qualify a building as nearly zero energy, we should fulfill various steps. And we go on. It's a sort of hurdle race with 3 steps to be followed. There is a video that you can watch where these things are described. Let's go on. So these steps are calculating and reducing the energy needs for heating and cooling, which have to do with the performance of the building envelope, its geometry, its recovery and ventilation. And this is the largest step. We have retrofits in Milano, where we went from 150, 200 kilowatt hour per square meter year energy needs to 20. So we went down by 80, 90%. And this is true also for new buildings that can be done to this target of 15, 20 kilowatt hour per square meter year. Then we can reduce total primary energy by having efficient active system to generate, to transform energy to fulfill the energy needs. And then the last step is to within this generation, choose generation from renewables in such a way to reduce the non-renewable primary energy. So the energy efficiency first principle, in fact, is lowering the indicators' energy needs and total primary energy. And as we see in many of the case studies that we have shown, and we'll see later, the first step is the largest one, where we have more possibility for impact, to go from 200 to 20 kilowatt hour per square meter a year energy needs if we design and build well the envelope. And then we go to the small amount of energy remaining should be generated from renewable sources, obviously. Go on, please. And the fact that we talk of net zero energy balance, net zero buildings, sometimes it's let's say a sort of shortening for it should include all the 3 steps. If we just concentrate on the last step, the primary energy balance over a year can be calculated in this way. What we export, renewable energy exported to the grid minus energy imported from the grid over a year. Over a year, we might be at 0, so the 2 quantity might be equal, but month by month, this would not be the case. Particularly in Europe, you would generate a lot in summer, and you would use a lot of energy in winter to warm the house. And you will not have a physically zero balance. Still, gas is burned and CO2 emitted. And in this balance, you are assuming that this balance on paper assumes that photovoltaic energy is stored in the grid and retrieved in summer and retrieved without losses in winter. In the reality, interseasonal storage costs materials, embodied energy as losses. There are possibilities to correct this. For example, in Italy and in other countries, the energy balance is calculated per month, not per year. Or the primary energy factors include these losses, as in the passive house certification. But the real physical cure to this problem is to strongly reduce the energy needs. In this way, the imbalance will be low. The requirement for storage and transmission infrastructure will be low. I think I can have one more slide. So in fact, one could, and there is a possibility in the standard that you just don't consider the exported energy to the grid as something which improves the performance of the building. This is generation of energy in the energy system, something different from the building. And you consider only the renewable energy self-consumed by the building in the qualification of the building. Not doing this and using this, let's say, virtual balance over a year means that when you do an optimization to bring to zero this virtual balance, for example, even if you have a local storage, you will not use it because the virtual storage on the grid, which has no losses, is much better, has no losses. So you are pushed to export rather than to self-consume, which is obviously physically not reasonable. So just to warn about this net zero concept and phrasing, which can be used if it is intended as 3 steps: reduce the energy needs, reduce the total primary energy, and then increase the share of renewable within the total primary energy. I have also slides on comfort, but I guess that Vincent will tell me that we have limited time, so I invite you all to go to the website where there is the first webinar on energy and comfort definitions, and you will find also in 20 minutes a description of these new indicators for comfort, which include as a key element for summer comfort air velocity on people. And so the use of ceiling fans or natural ventilation to cool down the body via air velocity is now fully included as a key element in summer comfort in the new standards, which was not the case till 5 years ago. It was there, but just with a minor role. I conclude here, and I let Vincent to go on to next speaker and continue. Thanks.
Thank you very much, Professor Lorenzo Pagliano, for this presentation that clearly define what we are talking about net zero. You highlight the 3 points, which the reduction of resources, energy and resource efficiency. We need to start there to make sure that we reduce the need of more energy. That will reduce also the emission that will happen. And then the issue of primary energy that need to be taken into consideration. Perhaps maybe just to mention that we normally also call that the embodied energy in the building material, that normally people don't see it, but that is the energy used to extract the material. Can be the stone, can be produce a brick, can also be to produce a cement. And then once this material is produced, it's now being used to build the houses. And then you put emphasis on the renewable energy, energy that is generated from renewable sources, which is very important. I think these are the different steps that need to be taken into consideration when we want to aim at the net zero carbon architecture. Now, I would like to invite Professor Francois Garde to make his presentation. I can see Grace. Can you send that presentation from your end?
I have it as well, Vincent. If you want, I can share.
Okay, please, Camilla, go ahead. Yes, François, vous êtes les bienvenus.
Thank you, Vincent. How many times I have to speak? Because I think it's...
you have 10 minutes.
10 minutes. Okay, I will try to be short in my presentation. So I'm here to give a complement presentation to Lorenzo, and I will make a special focus on social housing case studies that have been identified in this ABC21 project. So just for those who don't know where I am, La Réunion is a very small French island which belongs to Europe, near the island of Madagascar. Next slide. My speech is very important because we have to take lessons from the past to design new buildings. So that's why you have this slide. This is what we call the Creole house, and they use some passive solution because at this time there was no air conditioning. So as you can see, lots of trees around the houses, and you have solar shadings, and all the house use light materials, and they all use natural cross ventilation, so low thermal inertia vegetation. So unfortunately, that's what we have at the moment, lots of concrete. The vegetation has disappeared, and what happened in Africa and in some islands, tropical islands, is that it's a kind of copy and paste of buildings that we can find in Europe, and that creates a lot of discomfort. And of course, we need air conditioning. No trees again on this slide, only mineral spaces, and it's very uncomfortable. So next slide. We have also problems of intimacy, because the architects sometimes they don't think about intimacy, noise, and safety. And on this slide, you can see that the tenants they use they put blinds, but the problem is that they completely block the ventilation, which is very useful to avoid air conditioning in our latitudes. So next slides. First of all, so I'm here just not to speak in terms of models. I will speak about rule of thumbs, very simple solution, passive solution that we are easy to duplicate. First of all, the importance of trees. We have to plant trees around the buildings. We have to create a canopy, a natural canopy that allow to have a kind of microclimate around the building, and the maximum external temperature just remain at the top of the trees. So below, of course, the good example is at the top, and the bad example is in the middle of the slide. This is the first thing. And the second thing, we have to reduce the mineral surfaces. You have to avoid to put car parks around the buildings. And so another simple solution is to plant trees around the buildings and to put car parks underneath the buildings. I will present now two case studies. The importance of ventilation, very simple. We have to use, so we have different means of, the ventilation is used for different things. In Europe, in air conditioning spaces, in heated spaces, we use ventilation just to breathe. So we just have to renew the air, and we have to renew the air by 1 air change rate per hour. The second one is to evacuate the internal loads, but the third one is the most important one. It allows to create an air velocity on the users to minimize the temperature that the user feel, and so we have to create this air velocity of 1 meter per second by using natural cross ventilation. And in terms of air change rate per hour, that represents an amount of 60 air change rate per hour. If we can do that, we can feel uncomfortable to temperature like 30, 32 degrees. Creating an air velocity of 1 meter per second means to to use natural cross ventilation. That means that the airflow can go through the building. And one very simple rule of thumb is to create 25% of openings in the different barriers of the building. 25% of openings. For instance, if you have a facade of 20 square meter, with you need 25% of 10 square meters of openings. Next slide. So yeah, so now we come from theory to practice. This is an example of two bedroom units, and as you can see on the pics, it's very easy. You have a stairway that from the stairway you can have access to 2 dwellings, and all is naturally cross ventilated. Next slide. In all the social housing dwellings, the installation of ceiling fans is mandatory in the regulation in La Réunion. That means 1 ceiling fan for each bedroom and 2 ceiling fans. So 1 ceiling fan for 10 square meter. And it's very important, the use of ceiling fans, because it can reproduce the velocity of 1 meter per second. Next slide, Camila, please. So the first case study is located in the city of Le Port, on the northwest of the island of La Réunion. This is one of the hottest city in La Réunion. So this, in terms of passive solution, so the architect has of course planned vegetation around the building. As you can see around the building, no cars. The cars are underneath the building. We have narrow buildings, 10 meter deep maximum, 6 stories maximum. We have different shapes of solar shadings, and we use low inertia materials for the corridors. And the corridors are in timber, in wood, and they act to shade the main facade, which are made in concrete. And we have also BIPV, building integrated PV roofs, that are used as solar shading as well. So this is 2 pictures. So on the left-hand side, you can see the corridors, low inertia outdoor walk walls. And on the right picture, you can see vegetation around the buildings and still no cars. Next slide. You have an aerial view of the building project. In terms of renewable, we have PV, 88 kilowatt peak of PV plus 200 square meter of solar thermal. And as it has been discussed by Lorenzo, and Lorenzo explained the problem that the definition of net zero energy buildings in the tropics in Africa, it's more simple because the maximum of electricity generated by the PV is in phase with the demand. So for 1 square meter of PV, 1 square meter of PV can produce as much energy as 9 stories underneath, which is really important. So 1 square meter of PV produce as much energy of 9 stories underneath. And this is a nearly zero energy project. Next slide. You have the plan view of 2 units, 1 and 2 bedroom. You can see on the slide that air can go through the units. And one important passive solution is to use detached corridor to sort out the problem of intimacy, and outdoor corridors act as buffer space. They reduce the inertia of the building, and it has been, we have very good feedback from the users using this very smart and simple and replicable architectural solution. So another building project is the Îlet du Centre in Saint-Pierre. We have exactly the same principle. You can see on the aerial view that we have PV panels and solar thermal as well. And the cars are underneath the building as well. Next slide. This is more picture, and the architects, they are reproduce the native forest as it was before the first settlers come to La Réunion. So in the middle of we have a lot of native species, and it's really a forest that creates, it's a fresh island effect. Next slide. Here you have a view of the urban veranda, which acts as a buffer space. So all is designed in wood with a low inertia, and the users, they enter in their apartments by using the private corridors. And it's really, Vincent, I think you visited this project. In terms of comfort, it's remarkable. Another view of this urban veranda. Next slide. Here it's we monitored the let's say the different barriers and you can see on the cross section the temperature in the street is 37 degrees, and thanks to the first barrier, which it's represented by the number 2, we have the trees. And thanks to the trees, we can reduce the temperature, the air temperature, by 5 degrees. And then you have the urban veranda, number 3. We add another degree of gain in terms of temperature. That means when the temperature in the dwelling does not exceed 31 degrees C. So thanks to these passive, simple and passive solutions, trees plus the buffer space, and then the air is cooled by passive means. Next slide. Here you have the passive solution that are used for intimacy. The architect used vertical movable louvers. Next slide. Again, we have let's say a 3D view of one-bedroom unit, which is naturally cross-ventilated. Next slide. Renewables, of course, they are used on the canopy of the buffer space. And this is my last slide. So what solutions to design a very comfortable and affordable project in La Réunion? But the project that I presented are easily, it's very easy to duplicate this design in Africa. So first of all, vegetation and trees around the building, car parks underneath the building. Second, narrow buildings, 5-6 stories max. We can build very dense cities with 5-6 stories max. It's useless to design this kind of big towers that Leah showed, because it's you lose the connection with the ground, and you cannot use the expertise of the local companies to build this kind of 40 stories towers. Detached corridors with low inertia materials is very efficient solution. Of course, we have to shade the openings. We have to use natural cross ventilation with large openings, 25% of porosity. Ceiling fans must be installed systematically, and it works in terms of social and economic impacts. Thank you very much.
Thank you very much, Francois. I just want to say that, yes, you have really positive news about building in the tropics. You're actually saying that it is possible to use renewable to actually run an office whereby we could get net zero. We could get zero energy consumption at the end. I mean, in the sense that net zero carbon, I will call carbon, because we still need energy to run the appliances. We still need for the lighting at night in case we don't have batteries, even when we have batteries. So it is very important. I also like this focus on the density of the buildings, where you are talking about the 5 to 6 story, which is correct, because above that you need to lift, which is very energy consumer. So by just having 5-story, you allow people to move with a stair, and of course by moving they also do some sport in the process, which is also good for their health. I just before giving the floor to Daniel, I want to go back to Lorenzo. I think he has some clarification to make. Lorenzo, you have the floor.
Just 20 seconds. Perfect. I forgot, and you were correct, Vincent. The representation of this net zero via the energy needs delivered, the primary energy, is the representation and the assessment of the operative energy for running the building. And then we have also, very important, the embedded energy to produce the materials, which can be highly reduced by using raw earth, vegetables for insulation, and so on. So, and this is also obviously, as you know, part of what we try to describe in the project, and is in the reports that everyone can find. On the presentation of Francois, which I find always fascinating, the fact that they are actually applying the principles, the physics, to their buildings. I think it's important what he notices, that obviously there is more coincidence between the time of generation and the time of use in the latitudes we are mainly discussing, probably. At the same time, he can get to a almost zero balance instantaneously, because he has reduced highly the energy needs by the ventilation, by the low inertia. So he doesn't have this collection of energy on the balconies and so on. So the first step is always this very, very good envelope, narrow and so on, and then it gets to 0, which is great. Thanks.
Behavior change, the change of the way we see buildings. Thank you very much, Professor Lorenzo. With that, I just also want to thank Francois and Leah, because today in France is an holiday. Actually, we are actually using their holidays, and so this is very much appreciated. Thank you. I want now to invite Daniel to also share the experience of SCAT. SCAT has been doing in Kigali, and which we are also trying to promote these activities, low carbon architecture, where we are looking into issue of how do we build houses the way it used to be built using bricks, but with a different approach. Again, following the same principle that Lorenzo mentioned in his presentation, and also some of the issue that were also mentioned from Francois Garde presentation. So Daniel, the floor is yours.
Thank you very much, Vincent. Hello, everybody. Thank you, Vincent, for having me. It's always a pleasure to participate in these sessions. My name is Daniel Wies. I'm architect and urban planner, and I'm working for SCAT Consulting. We are a spin-off of the University of St. Gallen, like a company that is 45 years old now, and we are specialized in technology issues, in technology development and transfer from in developing countries and in transition countries. And I had actually the privilege to spend 6 years in the Great Lakes region, leading a project of the Swiss Development Agency on the decarbonization of the building industry and on the development of housing solutions that reduce, at one hand, the carbon footprint of urban expansion, but also reduce the costs. Maybe Vincent, can you go to the slides, or shall I share the screen? What is the preference? I can also share my screen if you want.
Maybe you share the screen so that it's easy for you to operate.
So. Okay. Can you see my
yes.
Screen?
Yes.
Okay.
Yes.
Yes. So let me. Okay, here we are. Yes, as I mentioned, I will present here a project of the Swiss Cooperation Agency. It is located in the Great Lakes regions, covering Rwanda, Burundi, and East Congo. And regarding the objectives which we have, the task which we have is, as I mentioned, decarbonization of the building material industry, introduction of affordable houses, and then, most important, developing solution to go to scale for citywide or even countrywide solutions. My second slide shows actually the challenges in terms of quantity, which we are talking about. On the bottom left, you see the absolute numbers of urban growth of large cities all over the world, and you can see beside India, Africa is the main urban development hotspot where we are, in terms of quantities, most new houses to be built. We are talking about 25 million additional people every year in African cities, so this is substantial, and is, of course, I think, one of the big challenges in urban development worldwide. Most of you know that the shift of the large cities will, from Asia to Africa will take place in the coming generations. So towards the end of the century, we will have 13 of the 20 largest cities in the African continent, while the biggest will count more than 80 million inhabitants, like Lagos, Kinshasa, Dar es Salaam. So what we are now developing in terms of supply capacities, housing solution, urban development patterns is actually relevant for these big numbers. And as it has been mentioned earlier, in Africa, most of the current urban areas are informal, unplanned, most of them very low rise, single-story buildings. And so this is the challenge which we are facing. So what are the solutions that we can actually reduce the urban sprawl, also in terms of energy consumption, transport distances, and so on? How can we densify it, and how can we densify these cities in a way that it can reduce also the climate impact of urban growth? So we in our region, then in the target group we have the operational costs of buildings or operational emissions are relatively low. Most of the people do not have ACs. They use relatively little energy compared to what we know from Europe or from maybe also other African cities. So the lion's share of the emissions are related to embodied emissions. So what's consumed or emitted actually by the cement factories and also by brick making, traditional brick making, which contributes a lot to deforestation. So accordingly, our first work was actually, I go back to this picture, was to introduce low carbon or nearly carbon neutral brick making technologies. This was possible by technologies that allow a swap of fuel. So instead of fossil fuels or trees, our technologies, which we didn't invent ourselves, but which we identified and transferred, they use bio-waste. So basically what's coming from agriculture and from wood processing, so sawdust and coffee husk and so on. So with this, we managed to make quite a strong building material that allows for storage construction with a minimum of concrete. We have developed a modular housing system, which you can see here, so which is based on a cube on the left side. I think Vincent has mentioned it. We are currently building such a cube at the UN compound in Nairobi. It can be visited in a few weeks. And with this, one can freely combine it to large buildings, large urban buildings from 2 to 5 floors. So it is composed of a free plan. So inside, every homeowner can actually shape subdivide space as he wants according to the needs. And it can be also easily be modified over time, which is very relevant in fast-growing cities. These are just some examples. This is actually after the presentation we had in 2017, very rapidly. We had, I think, within less than 2 years, we had 2,000 copies of those units. So it became more popular than we actually expected. Here's some insight of it. So the building system is based on these fired bricks, but we use a cavity wall system called roll-up bond, which has been developed, I think, in the early industrialization period, and then a bit forgotten. So we reintroduced it. It can be reinforced with concrete and easily carry 3 floors, and it significantly reduces the quantity of mortar and also bricks for its construction. Then another key element we introduced are the timber floors. Lots of the construction costs for storied buildings go actually into the concrete slab. So by introducing duplex, triplex buildings instead of horizontal apartments, we could actually introduce timber floors that are not only reducing the costs, but also reducing CO2 emissions, respectively, even storing CO2. Also, the partitioning walls, for partitioning, we introduced also light timber frame walls that can also be shifted easily once the needs of a family change through time. So in order to supply these actually hundreds of dwelling units every day that are required for following the pace of growth of these cities, we looked at how to organize the industry in a way that they can supply the quantity required. So we are currently establishing a eco park for low carbon building material production in Kigali. This is an illustration of it. So it brings together a variety of different producers, manufacturers of different material that all need to meet the lowest possible standards on CO2 emission. And here the plan is that actually these clusters of industry clusters supply entire buildings. So of course they will be erected, built in situ, but that as complete package of low carbon material can be delivered. Also the drawings and pre-engineered drawings reduce the planning costs and so on. So these are like the muscle for the supply of low carbon houses. And here we are still a bit on the beginning. We have, of course, all the models of the factories. We have tested them. We have optimized them. Bringing them together into an organized unit. This is something that will take place in the next 2 years, and we will keep you informed about this progress. But we hope that this could be a model that could be applied actually in many African cities. We are already in touch with quite a number of East African authorities who are foreseeing to establish such similar structures for the supply of their houses. Then the supply alone will not guarantee that the respective building principles will also be applied in these areas where it is most needed. So we work also on urban transformation methods for informal settlements. So you can see here our pilot building in Kigali, where we actually allow the local population, the inhabitants, to replace their houses with urban dwellings, which they can also shape and organize the way they like, with participatory methods, and also to accommodate additional people, additional families, in order to densify the neighborhood and to create also public space, green space that make these neighborhoods more livable. So this is the package on which we are working. We are doing this now for about 10 years. And right now we are working on methods to avail the knowledge and the expertise that has been generated with all our partners, also to avail that across the continent. And we are in touch with UN Habitat for that, also to see to what degree so community of practices like yours, like this platform here or others, can actually access this knowledge that has been generated. Thank you very much. That's my last slide.
Thank you very much, Daniel, for this presentation, and particularly for this reintroducing the bricks, which we call we will also say back to basic. We know that one burnt brick can last more than 200-300 years, and if we embedded that, we have a low carbon architecture. We use it to produce low carbon building material. It will definitely help in advancing the issue of the fighting of climate change. Just to mention that we are to bring this technology also in Zimbabwe and in Harare. We have already secured some resources, but for those who will be attending our Habitat General Assembly, we are building a demo house, which I'm happy to share with you now. It's just 1 minute. I'm happy to share with you the evolution of the work that is currently taking place. I will want to invite UN Habitat colleague to pass by. It's just near the print shop. We have been giving this space so that we can actually demonstrate that this project is possible. one of the advantage, and perhaps that was not really mentioned here, is that they high labor intensive, and also the fact that these bricks are burned using waste material, that in some cases, these wastes are just burned. So why not using it for useful use? So this building will be self-sufficient in energy. It will also show that with less resources, we are able to help African government that want to produce more houses. That this technology is possible. That is why we are implementing. We are showcasing it here. Now I will move to the next presenter since we are slightly running out of time. Professor Blaise Mumpo, I don't know whether you are Blaise. Are you? Can you share your presentation? Blaise or Albert?
Yes.
Yes, Albert?
Yes, thank you, Mr. Vincent. Dr. Blaise is sorry to be absent today because we have another mission. So I will present in his place.
Okay, thank you very much. Just a short introduction. We have seen the different example practices. We also heard about the theory behind it. We wanted to during this webinar session to also see what are the tools that exist that are outside there that can be used to design net zero or carbon neutral architecture. And upper that is an association of research, and they have been training building practitioner in using this tool that can actually help them in achieving the performance that we have seen, and also in inform the designer for a better selection of strategies, and also better selection of material. So so I have here Albert Jeffley. We will present on behalf of Blaise Mumpo, which is a professor at of environmentally architecture. So Albert, the floor is yours.
Okay, thank you, Vincent, to giving me the floor. So today we will talk about affordable and net zero carbon housing in Africa, and a solution that we give will be about age, which can make both possible. So what is the vision of net zero? We know that the community ambition to have a new building must be net zero carbon by 2030, and to ensure that we have to implement some strategies about the embodied carbon and also the operational utilization of energy. And by 2050, all building must be net zero carbon. All building include existing buildings and new buildings. And we know that existing buildings have, if we go to the next step, we can have the challenge and opportunity. The challenge of unsustainable construction, we have that 1.6 billion people.
Sorry, Albert. Grace,
yes.
Can you handle the presentation? Because we are still at the, or you can share, Albert, you can share the screen from your end so that you are able to control your presentation. Can you share?
Maybe it's better to
you share the screen. Yeah, it's okay. Okay, Grace will control the slides.
Okay, so please go on. Go ahead. Albert, please go ahead.
Yes, I can. Okay, we are on the next slide, please. So, okay, thank you. When we see the challenges and opportunities in Africa, we have that 1.6 billion people live in substandard condition in Africa, and half of 2050 buildings are not built yet. That means that architects and actors of the building construction have a lot of work to do and a lot of opportunity to get. When we see by 2050, the number of urban domestic dwellings could triple from 400 million to 1.26 billion. That means that we have to build house for these people that will come in 2050. And estimated 75% of the housing stock that will exist in developing countries in 2050 remains to be built. As we can see, we have a lot of buildings that does not exist yet, and we have to be capable of to be able to do a good construction, because we know that we are facing climate change actually, and we must build in a sustainable way and not also again and unsustainable constructions. We can move to the next slide, please. Okay, thank you. Here we have the impact of a typical office building over 25 years in India. As we can see, operational energy is the largest part of the impact of building in the environment. We have the operational energy that includes lighting, cooling energy, computer, and so on. So we need to address this operational energy and also the embodied energy to get to fulfill the net zero carbon ambitions. Next slide. Oh, thank you. Here we have that in Africa, we have $16 billion about the construction of the continent. And this is a new market that architects and banks can get to construct, to invest in green buildings as a good business. Next slide. Please, next slide, please. The presentation. Can we go ahead? Okay. Thanks. Another challenge that we have is that since there is a lot of ambition we have in our several concepts have been developed since, and we have green bonds, green mortgage, and green developer finance that have been put in place since, and we, even when the concepts are there is some difficulties in the country, specifically in Africa, but this represents an investment opportunity for us that we need to have. Next slide, please. Okay, thank you. So we ask ourselves, how can my bank verify the benefits of green or net zero measure? So in order to be sure that we have attained a net zero, if my building, if my construction is net zero, because we have used a architectural design that reduce the construction, we can have a lower bills for the occupants. And if we have a environmental construction, it can be sold at a higher value because most people want to fight against climate change and they are attracted by buildings that are environmentally friendly. We have also banks that invest in environmental projects, and so they can have people that want to build environmental construction can have a lower default rate, and so they can get the business opportunities. But what can we do? We need a validation tools to avoid issue as a greenwash, because many industry, many people are doing greenwashing in our life. So today we want to bring to you a new tool that we will present about, which is age. So move to the next slide, please. Next slide. Okay. So age, we move to the next slide. This is Can we move to the next slide, please, Camille? Can we go on to
next slide?
Okay. No, is
this one?
Can we go back?
Yeah, his internet is a bit slow, so.
Can we go back? Yes. Okay, thank you. There. Okay. So we have that age is a tool, is an innovative. Age is an innovative tool that has been created by the EFCA bank, and he saw that when we have a market, people want to be green, people want to be green, but they don't know how to achieve that. They don't know what tools, what can say that they are actually green. And looking at that, EFCA has put in place the age tools. So age use the whole system, the whole pioneering system that we can see in the next slide, please. Next slide, please.
Albert, I will just suggest that you just speak because we are running out of time, and just explain how the age works, and then what are you offering, and then things like that, so that we can move fast to also to the next presenter. Please go ahead and also summarize.
Okay. So normally we have that age is a tool that can measure your energy, water, and embodied energy. So with this tool, you can know if you have done some savings in your materials, energy, and waters. And so with that, we've lowered the operational cost of your construction of your buildings. And with age, you can also calculate the emission gas that will be for a year, as well as return on investment on the green element. And H is a tool that work across all building sector. We can work with H in new building, existing building, or with a refurbishment. So actually H work from homes, hospitality, retail, offices, hospital, and H is made of 3 components. We have the software, we have the green building standard, and the certification scheme. About the software, it is free. So architecture or anyone that want to work with that can use, and even if you don't want to have a certification, you can design your building in a way that will be green with the standard of the EFC. About the achievement of zero carbon, H1 for the people or for the building to achieve a 50% saving in energy, at least 20% in water and in embodied energy. After you have achieved 40% of your savings in energy, you must demonstrate that you have a 100% operational unity that will be achieved, that will be ensured by or supplied by renewable energy or on-site or off-site. Another solution to achieve a zero carbon with H is to have a credit carbon that corresponds to your 100% energy use by year. And what is the advantage of H is that when you look about the parameter that banks that have to finance a project, we can look that H correspond to each criteria that this bank or this group have to finance a green project. So with the H tool, you can directly have a green finance. But in the construction, we have some problems because most architecture, most actors does not have maybe the capacity to design environmental and to achieve a zero carbon. So a barrier that we have seen is the technical and the education. That is why we need to raise the awareness and educate people about H that they can use, and we support building capacity APEDAC support building capacity to promote the transition towards a zero emission and resilient built environment in Africa countries. And by raising awareness among stakeholders, communicating key messages and insight to the regional stakeholders and beyond, as well as disseminating promising education and training initiative and identifying any gaps that need addressing. So when we have a solution, we inform the government, and the government can facilitate the implementation of the strategy for the builder to have the construction. So that is the presentation that we have. Okay.
Very much, Albert Delpech, for this presentation about the validation tools, the H, which actually help in design and help also in assess the energy performance of the building. I like the issue that you mentioned about the greenwashing. If yes, you are right. There are a lot of people selling houses paint in green, and then they are calling in green buildings. We are seeing it happening many times. So it is important that we also have certification of buildings so that we make those buildings really net zero. The other point you mentioned, which I found interesting, is about the financing. I know we have been talking a lot about the different technology, the different example, but finance is also a key, a very important point. And the fact that more and more African countries are creating their green bonds, that is an opportunity. The green mortgage is also another opportunity. But most importantly, we are hearing more and more the issue of carbon finance. And again, this is an opportunity that we need also to explore and to see how it is how we could tap into this carbon finance, given that the net zero carbon is all about carbon reduction. So if we are able to reduce carbon, that will also help us to, maybe with the carbon finance, to reduce further the cost of the buildings. I know that Patriarche, for example, in some of their construction, they also provide loan as they build the houses. So again, thank you very much for this presentation. Now we will go to our last presentation of the day, and Francois Garde with Otalo. I do remember 3 years ago when we started hearing about the Otalo, we shared a video where we were actually telling people that we can we can transform the plastic waste into buildings, and many people could not believe it. And also pleased to inform you that during our Habitat Assembly, we will also be having a demonstration, a demo house, showing how this is possible. But again, the person behind this technology is here. Otalo, you have the floor. Francois, you have the floor.
Thank you, Vincent. Thank you so much for having us. And first of all, before I start the presentation, thanks to all the speakers for so many amazing and inspiring presentations. I really want to get in touch with several of you because I really see potential cooperation and synergies here. But I'll start the presentation as we are running out of time. Can you see the presentation now?
Yes, we can see, but if you can put it on, you can magnify it, it will be better.
Okay, why isn't it showing here? Okay, there it's showing. Now you can see it full screen.
No.
You
Maybe
can't see it
just,
full screen?
I can't see. Just go again on the share.
It's okay. It's okay.
It's okay. Okay.
Yeah, it's okay.
Yes, it's okay.
Okay. Okay.
That's good.
My computer is slow.
Okay. As Vincent said, my name is Francois Garde. I'm from Norway, and we have a patented solution that allows us to use, amongst other things, plastic waste as material, recycled plastic waste as material for a housing solution, amongst other things. A lot of the presentation tonight have been talking about the urgency for housing and the demand for housing. So this is something I'm not going to go through. It's a huge demand. It is 1.8 billion today, and it's going to increase to 3.3 billion by 2050. And housing means more than shelter from the environment. It's health, it's safety, it's added life value, and it's also identity. It is the foundation to create a future. This is what we call empowerment. This is the one who's been erected in Nairobi. And this is where the idea of Otalo is. is using one global problem, the plastic waste, to solve another global problem, the housing deficiency, and to make it adequate, affordable, and easy to build. And so I'm going to tell a bit more about that as we proceed. I'm going to be real quick since we are running out of time. Several of you guys, especially Professor Lorenzo and Francois, mentioned this. So design according to the climate zone. This is something that Vincent have imprinted in me since we first met, how to use the environment around us to make sure that the housing is run on as sustainable as possible. And our designs are using natural ventilation, courtyards, passive heating and cooling systems, cross ventilation, and our material are with low U value. It's not only about the housing itself. It's not about building a shelter, a roof for one's head. That's one thing. It's about creating communities for the future. This is what we are thinking about, and one of the bases we are working on. We are going to use the Othalo houses as platforms for creating, producing energy and conserving energy, distributing energy. But this is the next step in our evolution anyway, and maybe we will cooperate on several levels here. Transforming lives, the Othalo social impact and community empowerment. This is what we're talking about. We're talking about creating, using the plastic waste, using that as a raw material to build homes, to give a local workforce, because we're using local plastic waste to produce on an industrial level housing systems, which allows us to give work for the local workforce and together build communities. It's all about creating more than a building, but communities and a future for the next generation. This is what we are really focusing on. Housing, we see housing as a tool to do that. And we can use 3 hours to erect a house. Doesn't take much longer to do that. We have a IKEA-like solution to the system. It reduces the construction cost. You don't need heavy machinery and rigging. It's highly scalable. Tens and tens of houses can be built every day. We are using local recycled plastic waste, as mentioned, to locally mass-produce patented building modules that assembles into shelters and affordable housing. And this is also what we've been talking a lot about lately and during the presentations. What is sustainability? Othalo is highly sustainable regarding the plastic waste. One house uses about 8.1 metric tons of plastic waste. So 60 square meter equivalent, and it reduces, compared to a concrete home, the GHG equivalent of 46.3 metric tons of green production is 46.3 metric tons. So it's really working towards, and this is in the production and installment phase. This is how we see the world, but this is really important for us. We are not doing this ourselves. We have said that Othalo is not us. It's not us from Norway. It is what we do together. We need local partnerships. We need governmental partnerships. We need local empowerment. We need the locals to want to join us, from picking plastic, to recycling, to producing and erecting the houses. That is what we are really looking at. It is not a company. Othalo is meant to be an ID where we can actually create a net zero world together. So that is what I wanted to be short, and that is what I wanted to say. You will see more about the housing in Nairobi. The housing in Nairobi is meant to show the recycling of plastic, the reuse of the modules, that we have a cradle-to-cradle solution where we can perpetually recycle and reuse the modules and the elements to keep the carbon out of the environment and the plastic out of the environment. So that's what I want to tell today during this call. If there's any question, I would be happy to answer. Thank you.
Thank you very much. Thank you very much, Frank, for the presentation. And just to say that, yes, indeed, as UN Habitat is an agency mandated by the General Assembly to promote adequate shelter for all, and then at the same time also to promote sustainable urbanization, we really welcome all solutions that can help us to address the challenges that is ahead of us. That is not just the housing, but also the environment. We know, for example, I was just reading on the newspaper today that Nairobi, 4,000 waste is produced in Nairobi on a daily basis. If we look at this, at least 4,000 tons. We look at this, at least 1,000 tons will be plastic. So how are we using this plastic? So we see this solution as one way of addressing and a very innovative project. What you didn't say, perhaps in your presentation, which I wanted just to mention, I know we are running out of time, is the fact that with this panel can withstand up to 4 to 5 floors of buildings. So, which is also in line with what the previous speaker have mentioned. So now, I know that we have run out of time. I have seen some question being asked to Albert. I don't want, if Albert want to answer that question. It was from Professor Lorenzo. I have not seen other question. Is it because the topic was so clearly presented, or because it's something that is still difficult to understand? But again, just to go back to the plastic as a building material, I believe the reason why we are putting it here is that plastic was already, the emission was already generated when the plastic was done. Now using it to build houses, there will not be any additional, the emission that will be generated maybe to produce the panel will be very, very, very low. That's why we are calling it low carbon. And eventually, with progress, we'll also move towards the carbon neutral. So the floor is open for whoever want to ask question. Albert, are you still there? You want to respond to that question?
Okay. Thank you, Vincent. I want to as I said, H measure the energy needs and the hand budget energy, so the primary energy for the extraction, transportation, and transformation of your want to say your building envelope. If I can share my screen, I can show you a brief of a kind of.
Yes, maybe given that we have a lot of colleagues that are also leaving for other meetings, yes, maybe we can just communicate with Lorenzo and explain to him. Anyway, if it's something that can take 1 minute, less than 1 minute, please go ahead.
Okay.
Yeah,
Albert, we are waiting for you, Albert.
Can you see the screen?
Not yet.
Probably arriving slowly, the changes. It's a matter of the internet communication, probably.
Let me try again, please. Is it okay now?
I think the internet is slow. Anyway, yes, just explain, and we'll.
So when we use the H tools and you enter your different strategy to achieve a green buildings, H we show you the energy needs and how you are doing how you are saving energy by implementing, by adding some measure, some strategies. And also when you had that, you are using maybe a slab, you have a floor slab made of bricks or a floor slab made of concrete, the H2 we calculate automatically your embedded energy using that properties. So you will know your primary, your embedded energy, and you will know also what is the energy needs of your construction of your building.
Okay, thank you very much. I think we finally got the slide.
Yeah. Just a comment again on the language, because that will help us maybe in further communication later on, which hopefully will continue as facilitated by UN Habitat. Yeah, here it says final energy, which it's sometimes another word for delivered energy. So the energy measured at the meter, the gas, the electricity.
Yeah.
While the energy need is really, yeah, that's what. So my suggestion everywhere, not just in this case, is even continuing to use our own language. It would be very useful to have a translation table from the language used in, for example, this simulation tool or another analysis, to the language of the standards, the EN ISO 52000. So then we can easily compare, I don't know, our case studies in ABC21 and the results of EDGE or of Energy Plus, which uses another language yet. So this could be one of the small but important steps we can do together in the following. I don't think we can do it now.
Thank you very much, Professor Lorenzo. Thank you very much, Mr. Albert, for the presentation. I just wanted, in concluding this very interesting sharing of community of practices, I just want to say that we have invited Shelter Afrique, which is one of the leading agency that is promoting mass housing in Africa, but unfortunately they were not able to come. We wanted to hear what they are planning, but of course, most of the issue that they mentioned that was about the need of the housing, and then also saying that the financing should not be an issue, that the resources are also there. We have also invited someone from the ministry to talk about the building code, and then we were informed that the new building code in Kenya include energy efficiency measure and include also a minimum compliances for energy use in buildings. So basically, I can say that I can conclude this session, this special session, by saying that we have the politician with us, the policy is there. We have the financiers that are also transitioning towards green finance, and therefore we'll be seeing more and more green mortgage being established. We also know the knowledge exists. We have different tools and also practices. This has been demonstrated. Most of these housing that we were talking here, we have seen that they exist. They exist. In fact, even our offices here in Nairobi is a standing example of how to use energy in the buildings and how to use renewable energy. In fact, we export 35% of our energy is energy generated by our panel, our surplus. So these things are possible. So I just want to thank all of you, all the presenter, and also all the participants that have been with us right from the beginning, and then inform you that we are also planning to set up a platform on net zero carbon architecture, where we'll be sharing all these best practices, including tools that can be used to design buildings. We will also be sharing tools that can also be used for sizing renewable energy application in the buildings. So you will be informed very soon. This tool, we plan to have it set up before COP28, and so that we can continue the discussion. Thank you very much. Thank you, and have a good day.